This is the session going to be covering the online webinar. The going of the online webinar session is going to cover the user-defined macro, a feature IDEC again did not have on older series of PLC, the first PLC. Again, in order to do this exercise, you simply to participate in this session, if you like to write a question or comment or suggestion, you can write it in the chat box and hit on send it, and we will do our best. Usually we answer all the questions at the end of the session. If there's something you ask us we don't know the answer to, and there may be a possibility, we can get back to you because we cannot capture who the question is coming from, and we'll do our best to get back to you. Otherwise, we discuss the question at the end of the session, and oftentimes people get a chance to basically learn from other people's question. I hope that's the case with you. I hope this session will bring some benefit to you and offer some advantages and what have you. The user-defined macro, guys, basically is supported on all of our FC6A series, right? The one you see at the bottom, the brick style, all-in-one series, which comes in 16, 24, 40 IO, as well as in the Plus series, which comes with the 16 IO you see on the top left-hand corner of your screen, and the 32 IO. The major difference between those two, just in case some of you are not familiar with this FC6A series PLC, the major difference with the brick and the slim or the plus is the IO expandability. On the brick, we support up to 500 digital input output and up to 100 analog. On the plus, we support up to 2000 DIDO, and up to 500 analog thermocouple. So that's the main difference. Plus, of course, there's a lot other features and improved. I mean, the plus it's got a lot more speed and capability, memory capability, and also the 2 Ethernet port that supports 2 network interface cards and what have you. So the focus on this session today is the user-defined macro. Again, this user-defined macro is supported on all CPUs of the FC6A series. What is the user-defined macro? It's, first of all, it's an instruction. It's like a block, right? It's an advanced instruction or block. It's preceded by load instruction or logic, where when you want to execute the user-defined macro, you turn on this input in this case, or you enable the logic in front of it. When you don't want it to execute, you turn off the condition or the instruction in front of it. So it's an advanced instruction. What is it for? What does it do? What is the user-defined macro? As I said, it's really, guys, it's a macro instruction. It's a specific ladder program. Okay, specific ladder program where you can go register with a name and a number. You give it a name, you give it a number, and you do a specific task. And the purpose of the user-defined macro, ladies and gentlemen, is really to reduce your programming time, to make your program more efficient. So if you're doing, again, a task, a specific circuit task, and you want to repeat it over and over again, instead of writing the logic every single time, you just write it once, and then in the user-defined macro, you call that circuit every single time you want, and then you just change the input and output sources or whatever else associated with that macro. This is exactly what this is. Okay? You are allowed up to 256 user-defined macro in your program, from 0 to 255. So you're allowed 256 user-defined macro. Now, you can call the user-defined macro, let's say call user-defined macro number 5, let's say. You can call it as many times as you want, as long as you have memory, your memory allowed is in your program. You can continue to call it, right? Now, a user-defined macro, guys, is made up of arguments. Let's say, how many arguments? Basically, an argument is the steps of logic, if you may, right? Let's say you want an input controlling an output, and you're doing it 100 times. You can use the user-defined macro. you define the argument, there will be two arguments in that situation, right? An input going to an output. It will be two arguments. You're allowed 100 arguments per user-defined instruction, okay? But the example I was saying, we're gonna do an example, not very complicated, and just gonna have 8 arguments. You'll see in a second, we'll do it together. But again, in user-defined macro, an input going to an output, there's 2 arguments. I can call it, let's say, if I have 100 input controlling 100 output, I write it once with a single shot or not. I write it once and I call it 100 times. But for every input, control and output will be the same circuit, but I'm using different macro instruction. Again, it's really to conserve time, to simplify your programming. By the way, user-defined macro, guys, the data you supported in the user-defined macro, almost any data type, a binary bit, a memory bit, an input and output, a word, an integer, a double word, long word, or float are supported in the user-defined macro. User-defined macro, guys, are sometimes called something in like function block, function controller, custom controller, custom function controller, or CAN programming, depending on the manufacturer. They do the same thing. They allow you to do a specific program and repeat it over and over again. For those of you who are familiar with WinLDR, our PLC tool, we will do that example again together, guys. A user-defined macro is, honestly, it's a sub-program. Notice under the project window, it sits as a sub-program. It's almost like a subroutine. As a matter of fact, in the morning session, somebody asked me what's the difference between subroutine and user-defined macro. It's very, very similar. They're very similar. They're 2 separate programs you can call anytime from the main program to execute, right? The difference between subroutine and user-defined macro. The user-defined macro is made to simply go and change the input and output on that same circuit. And then all what you have to do, you can repeat the same circuit over and over again. You don't have to do it like write that circuit over and over again. And the subroutine, you can take that circuit, copy it into every subroutine and call the subroutine. So there is similarity, but the user-defined macro is a lot more powerful because it's a simpler, it gives you more access and more basically better repeatability and simpler repeatability to your program. So this is an example we will do today, almost the same exact example, guys. So in the example, again, we said you can do either 1 argument or up to 100 arguments. In our example today, we'll do 8 arguments. Basically, we're doing like a pump the skid test where I'm going to use a macro. I'm going to build a circuit to test the valve and the pump, which in real life you'll be testing all your piping, your filtration, your gauges, your alarm, and all that. So you want to test it before you ship it, let's say. So I want to write the circuit to do that. So I assign all argument to all the logic I'm using in that circuit. So I'm using start test memory bit, right? I assign it to argument number 1. Argument number 2, I'm using pump delay timer. I want to delay the pump after the valve comes on. So I have a valve. The valve comes on, and then I want to delay. I'm going to assign the timer delay, right, to delay the pump after the valve comes on. I have an output also into argument number 4. That's my pump argument. I have another timer, which is the pump runtime. I want to run the time for 30 minutes, 1 hour. For the sake of my exercise, I'm going to test the pump for 15 seconds. And then I have another argument for another memory bit or internal relay that tells me test is in progress. And finally, I have one for I'm going to capture the pressure, the tank pressure, system pressure when I do the test. So I want to take it and read it, take the raw data, read it in floating volume. That's exactly what I'm doing in this circuit. I have 8 arguments because I'm using 8 instruction in this, or 8 different devices, if you may, in this. So this is a circuit I'm doing, guys. The start bit is gonna latch a test start memory bit that's in process. I'm gonna with an SOTU because I'm latching the test in progress memory bit. Also, for one time, I want to capture the pressure coming from the pressure transducer I'm simulating in this example. And then once I'm in the test mode, I'm gonna immediately turn on the valve, the main valve, and then I want to wait 5 seconds, as you can see, by assigning the A2 for the timer, right? The delay timer. And then I want to use an SOTU to fire an off delay timer to hold the pump, to run the pump test for 10 seconds or any other desired value. And then at the end, when the off delay timer is done, I grab the falling edge and I reset the test. So I concluded this testing. I want to do it for valve and valve one, and then I'm going to repeat it 3 times for the sake of this. This is the same circuit. I'm going to repeat it 3 times for 3 different valves, 3 different pumps, and then, reading the pressure in every case. Okay, so now, and then in this case, I can go and call, like right now, I'm going to do 3 now, 4 or 5. I'll do 3. I'll do that test by calling the same user-defined macro 3 times, right? I'm just going to notice I'm calling this. I call in the user-defined macro, I tell it to call that circuit I built, which is this circuit, by telling it by assigning the exact devices to the first test, and then the second one I assign the second devices. Third one I assign the third device in one place. You will see how simple this is. Now I thought it would be relevant. We'll do, like I said, live example of that, guys. Furthermore, what I thought would be relevant to kind of spend like a couple of minutes on the memory on this PLC, because when we did this example, guys, originally, these examples during those online training webinar, we started with Modbus, MPID, and scaling and scripting, and we didn't really spend any time on basic circuits, which I think Britt and I working on doing for the week following the Easter week. So we have our online webinar extend till April 17, right? The week of April 20, we're going to offer some online training webinar where we can talk about basic programming, basic circuit. I thought, since I'm talking about devices, I spent a couple of minutes talking about the FC6A. So as you know, for addressing and such, and the memory capacity, so we have a predefined memory on the FC6A. We use I for input, and on the FC6A, as I said earlier, you can expand up to 2,000 I/O. This is a plus, right? 2,000 input, 2016 to be exact. The output, we use Q, you can go up to 2,000 output, 2016 output. Internal relay, you can do up to 15,400 memory bit or internal relay, right? And then you can have up to 2,000 timer, 512 counter, and you can have up to 260,000 data registers. 260,000 data registers. A little over 250,000 data registers. Those are 16-bit registers. So if you're all your data in your program, guys, is floating data or double word or long word, that number, of course, you cut in half, and you have up to 130,000. Still lots of registers. All our memory is dynamic data, of course. All the dynamic data is backed up by in the new design of the 6A, we opted for lithium battery with a life of about 7-8 years, depending on the condition. So the lithium battery backs up all the dynamic data, and then if you lose the battery is when you lose the data, right? And the power is cut. But otherwise, the battery backs up all your dynamic data that's in the data register and so forth, right? And then we have, of course, retentive versus non-retentive data registers. Now we're gonna go do the live demonstration of the user-defined macro as I described using the WinLDR software, which is one of the tools of the automation organizer. For those of you who are new to our, so I'm gonna go ahead and open WinLDR. So in order to do this, guys, I'm gonna go start. I'm gonna do this program from scratch with you, right? Because this is the easiest way to kind of explain it, right? So I'm gonna go ahead and delete. To delete, the easiest way, click outside the rung and delete. And then, so I'm gonna delete also the, I'm gonna go ahead and delete the, I'm gonna go ahead and delete this macro I already created. So I'm starting from scratch. Let me tell you again what is the purpose of this project. I'm gonna make this. So in this simple program, in this webinar, going over the user-defined macro, I'm gonna test the operation of 3 machines, each with a valve and a pump. Think about this way, or pump skid, let's say, whichever you. I'm gonna capture and monitor system pressure before each test cycle, right? So I'm gonna build the logic. I'm gonna build the logic used for the 3 valve and 3 pumps. Of course, I can expand it to a lot more. What I'm doing in this circuit, guys, right? I'm gonna use the start button to turn on the valve, and then I want to measure the pressure, and then I want to delay 5 seconds before I turn on the pump after the valve is on, right? And then I want to run the pump for 10 seconds. Basically, this is what's my circuit. So before I do anything, I'm gonna go to my project window under main program, since the user defined is, I don't have any right now, I deleted it. I want to go to the main program under new, I want to say new, and I want to go and define my user define macro. I want to go identify it and document it, right? So remember, you have 255 of them. I can go create number 4 or number 5, whatever you want, you know. I'll start with 0, is define 0, and you can give it a name. Let's say I'm gonna call it pump skid test program. I mean, I'm using the user define for the pump skid test. I want to call it pump skid test program, right? Now, as we said in the presentation, guys, a pump skid can have, let me remind you, you can have up to 156 of them. And every user-defined macro can have up to 100 arguments, 1 to 100 arguments, right? Depending on how much stuff you have to do, right? So in this example, I prepared for you this morning. I'm going to have 8 arguments, right? Each argument could be any device. An input is a device, an output, memory bit, timer, counter, data register. Any of those could be devices in your. So let's go identify the devices that I'm going to use in this program, and then I can use them in my, when I build the circuit, and then call them in my program. So the first one I want to do, I want to in the under device type, guys, I want to go and call the memory bit, and then this is my memory bit. I want to call it like this is start test memory bit. This is I'm going to assign it to start every test I want to do with this. And the second one, I want to use a timer contact, right? I want to use a timer contact. That's going to be my, the first timer, I want to do the pump delay timer. Pump delay timer. That's going to come after the valve is on. I want to use a timer delay contact, right? And then the third one, I want to use for the output. That's my valve, right? That's going to be my valve. And then the fourth argument, I want to assign another this for my pump. You can do them in any order you want. There's no pump in this circuit, right? Argument number 5, I want to do the pump run circuit, right? That's going to be timer contact, right? And that's going to be my pump run timer. Pump run timer. So as you can see, guys, in every user-defined macro, I have certain argument. I'm defining the devices that are going to belong in this argument. Now, so this is the output. A6 is going to be another, let's go to, so I have the first timer, okay, actually A5, sorry, A5 I said. So valve timer run, that should be not an output, sorry, this should be timer contact. I don't know how this got confused. All right, and then number 7 is going to be, I could have done that at the beginning as well. It's another memory bit or internal relay that's going to be my test in progress, test in progress memory bit, right? And then finally, the 2 data register, this is just to simulate, because I'm capturing the pressure. So I'm going to use the data register for that, right? So this is data register, both of them are data register. but one of them is gonna be my system pressure. That's in the raw data, right? That's coming from 4 to 20 milliamp, right? I'm gonna capture the pressure when I do the test. That's coming from the 4 to 20 milliamp, right? And then the last argument is also, but this time I want to take the system pressure, and then I'm gonna make that convert to floating. I want to infloat, right? Because I want to express, let's say, the pressure in float. That's just like the real pressure. That's the real system pressure. Okay, so let's go over this again, guys. In this user-defined micro, I have 8 arguments. The 8 argument, the first one is a memory bit. That's gonna be my start memory bit for the test. And then I chose the timer. That's gonna be the pump delay, because I want to delay the pump after the valve comes on. Then I have 2 outputs, 2 Qs that are going to be designated for the valve and the pump. The reason I don't put any addresses now, I define the device because I want to repeat that logic over and over again. Let's say I have 100 pump, 100 valve. I do it once and I call it every time I want. And then I had another argument 5, that's the pump run timer, right? That's to allow me to run the pump for given amount of time. And then A6 is going to be test in progress memory bit. A7 and A8 are the pressure, the raw data from the 4 to 20, and then the converted value. The converted value of the system pressure into float, since I want to express it into float. When I'm done, now notice, guys, I have 2 things. I have the main program and I have a user-defined macro, which is a sub-program or like a small A program. Now I'm gonna go and build that circuit I'm talking about, where I can call it anytime you want. That is the pump valve test circuit I need to build. And to do that, I'm gonna go to under view. I'm gonna go to less number of columns, so you guys can see a little bit better, right? So now, guys, everything I'm doing is gonna be based on the argument, right? So that circuit I'm building is I don't have to use AMs, and right now all my circuit is based on the argument. No AMs. It's all argument based. So I'm gonna go to basic instruction, grab it normally open contact, right? And then let me program. The first one I program is A1, right? Now I use only the A1 because I already defined it. It said, oh, okay, you want to program your start memory bit. This is gonna be starting there. And from there, guys, from the A1, I want to go ahead and use a single shot because I want to latch the test in progress, right? So I want to go to basic instruction, grab a single shot, right? And then I want to go ahead and latch the test in progress memory bit. This is the test in progress. I think it was A6, right? Yeah, test in progress memory bit. I'm writing all the A. Let me minimize it so you guys can see both of them. Okay, so when I hit the start button, this button is going to come from my touch panel or from my app or whatever. When I hit that start, is going to come in. So now what I want to do I want to capture the pressure at the time of the test. So the easiest way, I'm going to use a vertical line, shift the down button, or grab the pencil and grab a vertical line, right? Or simply you can, as you know, come here to the line under the editing, come here, and then click on vertical line. This is how you, again, this is for you who are not as familiar with our software. Okay, guys, right now, I want to go, I have a pressure signal. I want to go and convert it to a floating. So the way I'm doing that, guys, so you know, I'm doing, this is part of the example we did on the second day, March 24th. I know this is K-type, but I'm basically grabbing 3 pressure signals, scaling them inside the car. For detail on scaling, please refer again to webinar number 2 on March 24th. Okay. Right now, I'm grabbing 3 different live data coming from the analog card. Put them D0, D2, D4. Those is gonna simulate my pressure signal: 0 to 750 psi, 0 to 3000 psi, 0 to 1800 psi. This is just so I can put some live do a real life on my training demo, so I can show you how the pressure is captured for the three different sensors. Let's say you have three different sensors. So right now I want to go capture. The way you do that, I'm going to convert the raw data into a floating. So the way to do that, you go to advanced and go to data conversion. And I'm going to go and convert that data, right, from a word or an integer. In this case, probably I can use word or integer to a float. It's just so I want to express. I scale the pressure inside the card. I just want to show you how I can go ahead and move it to a floating. So I'm going to take the, that is, what is that? My pressure, that's A7, right? That's the system pressure 420. Move it to A8, which is the real one, the float one. All what it's doing, guys, is grabbing the raw data that's scaled and converted to a floating. That's all what they're doing. So my pressure before every test is captured and is in a floating volume. Now I want to hit enter to go to a new rung. And again, you don't need, you can do all in really one rung if you want. I mean, I kind of like to put it into separate rungs. Guys, please, for those of you who are new to IDEC, this line is it's a virtual line. There's no discontinuity here. So if your background is electricity and this discontinuity offends you, makes you upset, you can always go to ladder. In the editing under view, you go to ladder and you can click to show the line continuous. So actually there's no, you can see the rungs are interconnected. That break between rungs is honestly only virtual thing, But the rung, having multiple rungs is excellent tool for troubleshooting. Let's say you have 10 rungs and you have an error, you can go disable one rung at a time, right? I can go to a rung and disable that rung. So I don't erase it, I disable it. So it's really advantageous to have multiple rungs. It's a great tool for troubleshooting again. So if you have 10 rungs, you can disable a rung at a time to see if you can do the process of elimination. All right, so this is why and then you can document each rung. You cannot document ladder line. Like I can put comment, I can go to rung comment and write a bunch of comments here, right? I cannot do it per line, I can do it per rung. So this is another reason it's good practice to do, separate rungs and stuff like that. That's for another subject, another day anyway. So, okay, let me finish this, guys. So I hit the start button. I want to start the test in progress, right? And I want to capture. Now, what else I want to do? Let me come here. Now I want to turn on the valve, right? I want to use the same memory bit that I latched. That's A6, right? This is the test in progress memory bit. So the minute, let me make sure this when A6, so I went to normally open contact. And then I want to, the minute I turn on the start bit, I'm latching the test in progress. This memory bit A6. I want to open the valve, turn on the valve. Let me grab an output. And that's I'm gonna turn on my valve, and that's A3, right? We assign device to the output, which is A3 to be the valve, right, guys? Now, the minute I do that, guys, I want to delay. The valve is on, right? So the minute I hit the start button, I latch this bit, capture the pressure, and then what I do, I go ahead and open the valve, because this latches the first, when I turn this on, turn on the valve. Now I want to delay. Come here, please. The same thing. Grab a vertical line. I want to delay. I want to grab an on delay timer. I'm gonna go to a timer. By the way, guys, there's a million ways to do this basic circuit. I'm just doing it this way. So I want to on delay timer, because when the valve comes on, I want to go and delay 5 seconds to turn on the so the timer, the delay timer was the A2, right? So that's A2. I want to wait 5 seconds, right? I want to delay. So this is on delay timer. When the valve comes on, I want to delay 5 seconds, pump delay timer, 5 seconds to turn on the pump and run it for 10 seconds, right? Or 30 seconds, whatever you want. So one way to do that, I'm going to use a single shot. Again, guys, there's no single way of doing that. That's one of the easiest ways. So I'm going to turn on the valve, wait 5 seconds, and then fire an off delay timer this time, off delay timer, which works when TMLO, right, off delay. So I go to basic instruction, go to timer, excuse me, fire an off delay timer. That's the off delay timer, right? That is my the pump run timer, as you remember. That's A5, right? So I'm gonna go to A5, fire that timer for 10 seconds for the sake of time. So look, guys. So I turn on the valve when I hit the start button to start this skid test, valve pump test. Let's just memory bit, start the valve immediately, and then wait 5 seconds. And with an SOTU, because SOTU is going to give one shot for the off delay, so it's going to be energized, and the off delay will hold the time for 10 seconds. The pump, if you want a 20 second, you change it to 20 seconds. Let me go ahead and grab the pump now. That's A4, right? I think that's A4. That's going to be my pump, right? So I turn on the valve. 5 seconds later, I delay. I kick in the off delay, which is going to turn on the pump and run it for 10 seconds or whatever. And finally, guys, I'm done. I want to kill that. I'm going to reset that in process, testing process. So when the timer goes from on to off, the off delay timer to stop the pump and everything, I want to grab an SOTD, right? Because I want to take the falling edge of that timer, right? SOTD, right? And then I want to use the SOTD to kill that, to reset that test bit. Again, you guys will have access to this program and the recording. So I want to go grab a reset now. Put it here. I want to reset the test in progress, which was the A6. I think I deleted this one. That one should be set actually. I somehow deleted that one from above. Okay. So now after I'm done, let me go over that one final time, guys. Okay. How did I get this? Sorry, guys. I erased that by mistake. A1. What the hell happened? Who knows, right? So A1. Let me make sure now we're okay. So let me go over that one final time, guys. Start button, right? So the start button. With a single, I latch that memory bit, test in progress. I capture the pressure, right? I'm really convert to a float in here. And then I turn on the valve and the program on delay timer, 5 seconds. And then I fire with an SOTU because I want to do it once, right? SOTU, it's only once. But the off delay timer, it needs one, it starts working when you cut the power from it. And this is going to give it a pulse and stop, right? Because of the SOTU, the rising edge. Then the off delay timer will hold that pump for 10 seconds to test the pump for 10 seconds. And when I'm done, when the off delay timer turns off, I use it to reset the test in progress. Okay? So let me go ahead and go to, so now that's the circuit, guys. I want to go repeat over, I can repeat this circuit 20, 30 times for 20, 30 pump and valve. But I'm going to go to the main program and do it. I'm going to repeat it 3 times for 3 different tests, right? So now in the main program, guys, I go to the main program, right? I go and then grab an open contact. I want to, in the main program, call the user-defined macro. I'll use M0 to do that, right? I'm going to use M0, which is the start test bit. This is going to be the M0 in the main program, right? Now I want to go grab the program that uses the user-defined macro. So as you know, guys, you have the basic, the advanced, and the macro. I want to click on macro, and it's under macro. And this is what it is. Or you can always, on your keyboard, to UD, it takes you the same thing on your keyboard. I like the menu because I don't have to memorize anything. So I'll go. Now, the user-defined macro, it's only for one argument. Double click on it. It says, so I found it, double click on it. It said, which user-defined macro? If you already defined it, we already defined ours. It's right here, right? I have to go get it. That's number 0. This is how I call it, right? So, and I come here and say, I want to call the user-defined macro, double click. And I go in the down, pull down menu, find it. Said, oh, okay. That's the one you defined with 8. I said, that's it. And then it asks me now, notice it already has all these programs in there. All the devices for the circuit, guys, is already there. I just need to tell it which one for which step. So I'm going to do the first test. That's going to be M0 for the start button. And I'm using timer 0. That's the first one. I'm using Q0 for the valve, right? For the first test. I'm using Q1 for the pump for the first test. I'm using T1. Notice I'm just populating this really quickly. I'm using M1 for the test one complete, or this is really now written complete. This is just test in progress. Test one, test one, test in progress. This should be really in progress. Test in progress. I changed this memory bit actually because that's really better explanation for it. And then this one is my the data register. I'm gonna use D0, which is the raw data from the 4 milliamp, and this is a converted value, which is D100. Okay, that's it. So now when I click OK, guys, notice how it stretches this because I had it for an. I mean, this is fine, by the way, guys. The number of columns is only for printing purposes and viewing, but I don't like it. So I'm gonna go back to 12 because I needed like 12. Now it works fine, right? I don't need to do anything to it. And now I wanna go. I wanna repeat this logic 3 times for 3 different tests, right? So now instead of writing the circuit 3 more times, right, guys? Instead of writing the circuit, let me make sure this is in progress here. It changed it right here, right? So instead of writing the circuit or calling or doing subroutine or whatever, right? I can come to the main program, guys. I can copy and paste, right? So let me copy this. A copy. Come here, paste. I want to do it twice, right? Paste. Let me do it one more time. And again, I will do it on 3 different runs because, again, it's really excellent troubleshooting method. So now I want to repeat that circuit, that test for 3 different tests, then 3 different pumps and valves. In the meanwhile, when I'm doing that, of course, when you run each test, you're testing your piping, your filtration, your gauges, your alarm, and everything. But now, guys, look what I have to do. In here, I gotta go to the basically the I double click on the user-defined macro. It's the same user-defined macro. Instead of M0 now, I'm going to the second test, which is gonna be M2, second test, and the timer is gonna be T2. I just changed the address of that circuit. The circuit remains the same, right? And the address of the output and input and devices for the second Q3, and this is T3, and then this is gonna be my M3, right? M3, and that's gonna be my D2 and the 102, right? D102. So that's the only thing I changed, right? That's gonna be, notice the same circuit appearing here, but the same thing for the test. I just changed the devices, right? So M2, D2 for the on delay timer for the second pump. The second valve is wired to Q2, and the pump is Q3, and then timer 3 is gonna be my pump 2 run time, and then the M3 still saying, this is test in progress. It doesn't matter because it's taking the original one, right? And then this is raw pressure, and then finally, guys, the last user-defined macro, the last test I want to do or function block is gonna come from M4, right? M4. This test number 3 memory bit, and then I'm gonna go and change this now to the test 4 devices that I want to run, right? And that's gonna be my M4 for the run test, right? And then it's gonna be here your timer 4 for the pump delay, and then your valve is gonna be Q4, valve number 3, and then I'm changing the devices only that. Everything else remains the same, right, guys? T5, and this is gonna be my M5. That's my complete or test in progress, whatever you want to call it. And then D4, and then this is gonna be my true pressure D104. So notice the same circuit, same setup. I'm just changing the devices connected with that circuit in one place. And again, you can do something very similar with a subroutine, but this is really the best way of doing it, right? So now I can, I'm done with this. Let me save this project, right? Now I'm ready to download this project, right? So I go to the online tab, make sure I'm connected. I think I was on download to test this project, right, guys? I'm on SP number 12, and I'm gonna go to online, download the project. I'm gonna make sure it's going to number IP12 and say yes, okay, and then go ahead and download. And then we'll get test chance to go test this project, guys. Look how easy it is. Now go to monitor mode. Now, guys, what happened? Since I'm really slow typer, I want to create it. Thanks to Brett Davis, who inspired me to do that. He did that. I went and so for you to see that, I went to create the user-defined macro custom monitor. Very, very helpful, guy. Why? Because custom monitor allows you, like in this case, I want to look at a specific one for every test, right? I want to do one thing. I like the output to look, to when it runs. Okay, so I'm gonna show you the pump when the valve and pump when it's on, right? So let me go grab that and put it next to this guy, right? So I'm gonna put it next to it, right? Now I have now I want to turn on the first user-defined macro. I'm gonna go fire M0 from I have a touch panel connected. Let me do that. So I hit I0. It's calling the valve comes on. 5 seconds later, the pump comes on. And if you can keep your eyes on the timer, guys, 10 seconds later, the pump is off. It resets everything. Ready to let's test it one more time. When I hit the test button from my HMI, valve comes on right away. 5 seconds later, the pump comes on. And then I would run the pump whatever desired time I have, and bam, then everything's off. I tested, everything looks good. I checked all my piping, the filtration, the gauges, everything. Let's go test the other one. So I'm gonna go to custom number 2 now, because now it's different devices. I need line it on top of the first one, right? So now let me test. The second one is the M2. So M2 now, valve number, I'm testing the valve number 2. 5 seconds later, the pump comes on. The pump is gonna run for 10 seconds and turn off. Bam. 3, 2, 1, bam. Everything. Let's test it one more time. So now I'm testing the second running second test. On the 5 seconds later, the valve is on. Then now, guys, just want to show you something very, very important. If you're testing, even in here, you don't have to stuck with 10 seconds. Let's say right now, test number 2, I saw something funny, so I want to test it longer. So I can go change the duration, right? So I can go change this to 30 seconds now, and I want to change 10 seconds. I want to delay the pump 10 seconds, right? And when the valve comes on, I want to delay the pump. I want to delay 10 seconds to bring the pump on after the valve, but I want to run the pump for 30 seconds now. So let me try this. Now notice, guys, the valve comes on 10 seconds later for the pump to come, not 5, because I changed it in the monitor mode. 10 seconds later, bam, the pump comes on. Now the pump is not going to be on for 10 seconds. I change it to 30 seconds. So this is really worth it to mention to you guys when you're doing those tests. Right now, the pump is I'm testing it for 30 seconds. I changed it. Whatever I changed, it will be held by that register unless the battery dies and it gets turned off, or unless you re-download the project. So the changes you do from a touch panel, the changes you do from HMI or from the app or from the online monitor, it's always permanent unless you re-download or you lose the battery. Otherwise, the PLC remembers those changes that you entered in the dynamic part of the memory because it gets backed up, right? So right now, every time I do it, it's gonna use a new parameter. It's gonna wait 10 seconds to turn on the pump after the valve comes on, and it's going to bring the pump and run the pump for 30 seconds now instead of 10 seconds. Does that make sense, guys? Please remember, that's very important. In this case, for test number 2 only, I changed the original value to whatever I want. Note the number of devices did not change, only the preset, right? And the way you can do it. Okay, so after 30 seconds pump off. Okay, let me go test the third one, make sure it works. Now I'm gonna bring the third one, right? Now let me go and test the third circuit. So the valve comes on. 5 seconds later, the pump comes on. It's gonna run for 10 seconds and stop. So all my 3 circuits are, the 3 user-defined macro are working. I can go ahead and turn it again, right? I can do it again, right? Same thing. 5 seconds later, the pump came, and then we're gonna run the pump for 10 seconds, and that's it. So now, if I were to add another, let's say I have, it's really easy, guys. I can add another one to call the same circuit, guys, to call the same circuit. And every single time to call the same circuit, right? And, again, I said that earlier, I can, if this could be really one, I can go to join wrong. This could be one wrong. So this is what I had in this user-defined macro. I can repeat over and over and over. All what you have to do is I can repeat this. I already defined the argument. I can repeat this circuit as many times as you want by simply calling the same user-defined macro. I'm calling the same user-defined macro. The only thing I'm changing is really easy. I'm changing only same execution, same behavior, same things happening, except I'm changing the sources in the main program. I'm changing, instead I'm 0, it's I'm 2. I said timer 0, timer 2. But it's repeating the same task or the same task in this case. I can do 100 times, 200 times, whatever you want. So basically, this is what the user-defined macro is. We will do another session of that on Monday, I believe, to go over more advanced instruction. In this case, I only use simpler logic it's really simple, very simple logic. 2 timers and 1 conversion, to convert the pressure into a floating volume. And so I can capture that floating volume. One more time, guys, which I didn't, I got so busy with the macro, didn't show you I'm sure some of you saw it, but again, like when I go to this one more time to show you that when I turn on the first test one more time, notice, so I turn on the test. Let me test this one more time. I turn on the valve. 5 seconds later, the pump, and notice I captured that pressure based on this, right? So the pressure was running for 10 seconds, bam, and then turn it off, then everything off. So when I did the test, I did that. Let's do the second one. So the second one, let me grab the second one. It's running a different pressure point, let's say. So let me test the second one. Now the second one is what happened to be at 2700. Like right now, notice pressure is changing, but I already captured it. Remember, I'm capturing the pressure at the point of the test. Notice my pressure changing. I don't care. Now, right now the pump. Notice it remembered I'm running for 30 seconds right now. So now, guys, by the way, like right now, I want to speed it up. I can go to 2 and jump, or even I can override the current. I can override the preset. Anyway, guys, now notice now the pressure. I'm only capturing the pressure at the point of. I'm capturing the pressure, guys, at the point of running the test. You see now I'm running. It doesn't matter if it changes the valve. I'm testing at that specific pressure when I capture the pressure when I turn the thing on. Okay, so right now again it's 30. The valve is on, and I can jump it. Bam. So I jump it, and then finally one more time the last one. Use the define macro 3 if I want to test it. The same thing. I run the valve is on. It's 698.0 psi, and then the pump came on after 5 seconds, and then 10 seconds later the pump is off. Damn. Okay, guys, that is all what I have on this user-defined macro. Let me go to your question to see if anybody has any questions on this. See if I can hopefully answer them. Let me go to start with the top. See if, let me go to the top. Sorry, guys. Seems like there are a few questions here. Let me start with the first one. Can preset value dynamically change the default value if logic is changed to do so? I think I already answered this question with demonstration. Yes, the answer is yes. Preset value, because they belong as inside. Only devices cannot be changed dynamically, but the preset, absolutely. The answer is yes. Great question. Let me go to the second question. Can you reuse tag names that are in the main program or use macros? Yes, absolutely. You can use tag names that are used in or other macros. Yeah, you can use the same tag name, different macro. Absolutely. Yes. No problem whatsoever. Yeah, because it's like you're using that device in multiple circuits. The answer is absolutely yes. Let's go to the second question to the FC6A. Let me see, what is this? I don't have macro under the program. Okay, for this question, guys, please make sure you select this question, guys. Please, you make sure you select FC6A. If you were late in the presentation, I did mention, guys, that the FC5A did not support user-defined macro. So if you're a PLC program right now, look, if you're in the bottom left-hand corner or under configuration PLC type, please make sure you have D16. If you have D16, then you can go to view, project window, and you should have under program, you should have user-defined macro. If you don't, I'm assuming two things. You either have very old version of WinLeather or you have different PLC selected. Let me show you how that. If I go change the PLC, let's say to, you know what, I don't want to, let me go grab another instance of this software, because this could, you know, this could, let me go get, I don't want to mess up this program. If somebody has more question, I have to refer to. So if you have an FC5A, guys, if you have an FC5A, then that's another instance where you're not going to get this. So let me show you this. If I go to, I opened another instance of the WinLeather software, right? And then if I go to the FC5A, configure PLC, anything but if I go to the 5A or the FT1A or all that doesn't. So let me go to the FC5A. You're not going to have user-defined macro. If I go to view, project window, and under program, see there's subroutine only. So that's probably your situation. Whoever asked that question, I can't get that name very well. So anyway, so let me go to this question. They skip, my bad. Project confidence. Okay. Sorry, I skipped a couple of questions. There's more question I skipped, I think. Question, go to. Any pre-built macro available? Yes. Like for instance, guys. Oh, so great question. We don't really have any pre-built except for the high speed. We do have a pre-built macro for the high speed for the IDEC AMCI thing, the high speed stepper. So those are available on our website. If you go to the IDEC user-defined, so those I know are available on our website, us.idec. But I think we should do more. The only one I'm aware of are the ones that are under, let's see, the user. Let me show you there are some. I'll show you how to get to them, since it's a Friday. Probably we have a little bit of time. Maybe under the AMCI stuff, guys. So if you go to any of this, let's say all-in-one, so we predefined this macro for the IDEC partnership with AMCI, the stepper and servo company. So you can get this as an IDEC part number, a controller, an amplifier, and a motor. If you go under download, and you see, you can get the user-defined macro. So you can find bunch of user-defined macro. So we did, to answer your question. So the only one I know available, they're onto the for the high-speed output stuff. And you can see now, I'm gonna open it. You're gonna see them all. They automatically get loaded, right? So let me show you. So that's to answer your question. Do we have some? Yeah, in this example, I believe there's some built-in. If you go to view, and then you're gonna find see right here that they already loaded up. So we have about what I think about 18 user-defined macro pre-built into, and if I want to show you this, and you can tell that's a lot of stuff in every user. This one has 14 arguments. If I go to the jog function, it has what 5 arguments. If I go to, I think relative move, maybe yeah, I think the first one probably the most 14. So yeah, so that's where you can find already some user-defined macro. Absolutely. All right, let me see another question. So that we should build more to make it easy for people and make it available. I'll look into that. Basically, guys. Let me see what this question. Can preset value dynamically change the default value of logic exchange to do that? Yes, I think I already answered that question. Yes, you can, because dynamic values are not they're outside of the argument. They're part of, they're written to the dynamic memory. There are any, I think I answered that. Let me see this. Okay, this is a new question. Does the macro become part of your library, or do you have to write a new one every time? No, it's part of your library. Once you write it, you can, as I demonstrated, you can get to it every time. You can go and get it every time. When it is here, back to our project, you can go and get it every time you want. It's here. You can get to it every time. That's right there, right? And by the way, you can do password protection on the macro and things like that, right? Oh, one thing maybe somebody will ask, but I'll mention it if somebody. Let me see if let the viewer know that you can also use MQD in the macro program, but they will be constant every time you run the macro. Yeah, I think that's the whole idea about the macro, guys. You can use them a million times, but all you have to do is to change the device address of the different devices, right? I mean, but yes, any data register, any M and D, they could be used. Only the presets could be dynamically changed, right? So now, let me see next question. Is there no screen shared, or is my PC having? Oh, sorry. I think I'm starting to get to the beginning. I forgot to turn on my screen. I can't believe that's not rocket science. I have typed the link to the webinar but incorrectly. Please retype the link missing day one. Okay, so I don't know what, guys, let me take you to this PDF file. Okay, guys, so this is the link to all of our webinars. If you want to take a screenshot of that, if you don't have it, let me repeat that. To register to all of our online training webinars, that is the link to those every day, depending on the topic, right? Now, to go watch, so you can take a screenshot of that, or the easiest way to capture, right? Or you can go, the second thing, to go listen to any of the online training webinar. Kathy of our Marcom nicely put them in this link that it takes you to all the different schedules. So far, we had 10 days of online training webinar covering. Actually, the Modbus, we had bad audio. We're gonna repeat that. We had the PID, we had the scaling, we had the scripting, we get the high-speed input, high-speed output, the web page, and the email. And now the user-defined macro. By typing this link, if you take screen capture of it, it'll take you to the YouTube where we went and listed all this file, guys. So please feel free to go and go ahead and do that. And then if you miss any of that, if the webinar you like to go back and look at it, it's all of it there. I don't have the macro. I already answered that question. So please make sure you select FC6A, and then you'll be okay. Manually entering the playlist URL address did not work. Oh wow! So I'll let you guys should have gotten this button with. Oh wow! So this did not work. I think this works. I don't know if you mistyped it. I'll check with our Marcom department, though, guys. Let's see. 6A. Oh yeah, okay. Somebody already maybe answered your question, doesn't it? I think I answered that. Let me see if I'm going the right direction now. I think that's all, guys. Make sure the answer that so maybe the tag name and comment are only defined. Yes. Thank you, guys. So, guys, yes, the answer is yes. So in your user defined macro, guys, the right now I use comment. I of course can use if you want the same thing. I can do start underscore the same thing. I can use both either tag name. I think we're gonna spend the whole session memory bit. I can do it that way. We know we really use comment, but you could have used absolutely. You could have used tag name. We're gonna dedicate one training for tag name versus comment coming up, honestly. So yes, the answer is yes. You could have done that for sure. Let me see. More question. Okay, guys. I believe I answered everything. If maybe not any previous. Okay, yeah, I answered everything. So, guys, if you have a question that I didn't answer, please email me elias@idec.com. Me and Mr. Britt Davis are in charge of this online webinar. Britt, BRITT @idec.com. Elias@idec.com, and I'll be happy again to or you can follow all log on onto the any of the link you get from IDEC to and then to send us questions. Or so this is mine and this is Brett@idec.com. Email me if you something. I'm gonna make the program, all the documentation available to you, please. So let me when you go and log into the link I just showed, or when you go to you get subsequent email from IDEC. Again, you can go email me or Brett if you have any question. All the material, the program, and you can go listen to the recording after this session. Thank you so very much for taking time from your busy week to join us. Please stay tuned for a lot more online training webinar and product training coming up. Thank you for your time. Please be safe and hope to see you on a future webinar. Have a great and safe Friday, guys. Thank you.